purpose of this demo is because I'm going to talk to you about the concept of tangency. What is tangency? Yeah, when curves are smooth, like when you have an arc and then the reverses arc, that you don't get a sharp point, that is a smooth transition, right? So concept of tangency, and it's actually quite important when your model gets more complex. So I'm gonna do a real quick one of this stool. I'm gonna fake it for the sake of this demo. Okay, so here's my stool and a straight line, right? Okay, so let's just pretend that looks like the stool, and we're gonna lathe it. Okay, Ricky. So I'm gonna type in lathe. Or is it revolve? Sorry, it's a different. So I'm gonna select this curve, and then I'm gonna say revolve it around this object, this center line, and it's gonna spin it. So let's take a look at it from. Yeah. So so this is not a tangent curve because you got a sharp point. Got it? That's not a tangent curve. So I want you to understand that. So now let's do another one. And let's try to do a better job of this one. So I'm going to go ahead and draw a curve. Like I'm going to assume that the bottom of that, well, first of all, let's draw a center line. It's always good for you guys to have us like reference lines. And I'm going to start with this tool here, which is the control curve tool. I'm going to assume that the bottom of that line is somewhere here. Is there a near? There, snap. So, and then I'm going to click here to create the middle of that arc, if you will. And then I'm going to click here, and then enter. And then I'm going to click, and then I'm going to do these real quick. I'm going to assume that you guys know how to do that. Alright, so I'm going to take this shape across. So I have this arc, yeah? This is not correct, by the way. So I want to show you why it's not correct. So I'm going to do revolve again. Oh, wait, actually I got to join all these. I'm going to do revolve again along this thing. Okay. This is also not a tangent arc. I exaggerated it, but you see how I get a point? So that's not a smooth transition, right? So how do you get that smooth transition? What determines tangency on the curve? So if you guys really understand this part, your models are going to come out much more accurate. So I'm going to go back to front view. Tangency, when you have a curve, like a 3-point curve here, that's the pinpoint, right? If I let me center this a little bit. So as long as this point is the same point as these two arcs, then that's going to be tangent. But if you're only drawing half of an arc, it's really hard to make sure that tangency is going to be there. So for instance, if I take a point like that, and then I mirror that, super important concept here. If I mirror that, you see how I get a sharp point? So how do you not get a sharp point? This is how you do it. Very important. So I have the beginning of my arc. I have, before I get, let's say the midpoint of my arc is here. Before I get here, I'm going to click on my control point here. And then my next point, I'm going to hold down Shift, which allows it to be on a straight line, same line as that point. I don't know if y'all can see it. So I hold down my Shift, and then I click that. So believe it or not, somewhere like right when it gets here, I'm going to turn on my control point. Between here and here, somewhere here, it actually starts to flatten and get straight, like in a very micro way. So that when I mirror this object, that transition is perfectly tangent. That concept is very, very, very important. So knowing what I know and knowing what you guys know now, if I'm drawing this and I'm concerned about tangency, meaning I want my surface to be clean and smooth, I'm going to start my bottom of my arc here, and then my next point immediately I'm holding down shift so that it's on the same line, and that maintains tangency across this midpoint. Then I'm going to come up here. Yeah. Then I'm going to come up here, and I'm going to stop. And then I'm going to draw a straight line, and then of course do my thing, going across, making your shape. Pull that out of the way. So let me take that. I'm going to hit F10. Now, as soon as I move this up and down like this, I destroyed my tangency, right? But I could actually move this thing as far across horizontally as I want, and that'll maintain my tangency when that thing gets mirrored. Very, very important concept. So then now, I can select both of these, join them, and I'm going to revolve along this center point. And then you'll see, as soon as so this guy here, I put an EMAP on it. You see that top surface? There's no point. There's no hard edge. It's perfectly tangent. Whereas this guy, I put an EMAP on that. You see that little concentric? Right? Difference between a good, clean, tangential, watertight model versus the crappy model that you guys would normally give me. All right? But that's technique. That's really understanding how things work, right? So if you maintain the last two control points on the same plane, then when you flip it or mirror it, you're going to maintain tangency. Super, super duper important.